The Best of Our Knowledge explores topics on learning, education, and research. Coming up, the solar cycle is in its maximum phase, causing the northern lights to recently be visible in lower latitudes. We'll learn about the science of auroras. And amid a drought in the northeast United States, we'll learn about the causes and science behind wildfires. I'm Lucas Willard, host of The Best of Our Knowledge. This is The Best of Our Knowledge. I'm Lucas Willard. Something's happening with the sun. The solar cycle is in what scientists call its maximum phase. Increased solar activity is linked to auroras being visible far from the polar regions. In mid-October, the northern lights were visible as far as the southern U.S. Yours truly also caught a glimpse of them in upstate New York. To learn more about auroras, I spoke with Hugh Gallagher, an associate professor of physical science at SUNY Oneonta.
The Earth exists down in inside a magnetic cavity called the magnetosphere, and it's the region dominated by the Earth's magnetic field. And there are lots of interesting populations of particles in this magnetosphere, including going out into the tail. And these particles in the tail bounce back and forth between the northern and southern hemispheres. And occasionally, due to something in the tail or something in the upper atmosphere, let's say about above 1,000 kilometers, something will accelerate these particles towards Earth. Many of them are mainly electrons, and they penetrate deep into the upper atmosphere, where they can hit the atoms and molecules that are there, cause them to go into an excited state, and when they de-excite, they emit colors specific to who they are.
So when we commonly refer to the auroras as the northern lights, this is not a reflection of light from space.
No, it is actively caused by particles following the magnetic field of the Earth towards the poles, both north and south, and raining down in the upper atmosphere. And when they do, they excite those atoms and molecules, and they glow with specific colors.
Yeah, I wanted to ask about the colors because as you and I were just chatting, I had gone outside a few weeks ago and looked up, and the sky looked as if it were a wine red color. Yeah. And when you look at the northern lights through your telephone, through the phone camera, the technology in the phone can really make those colors pop. But where I was in upstate New York, there was a wine red color, but not too far away, photos that friends shared with me, the sky looked green or a purplish color.
Yeah, so I can't speak to the specific observations that you saw, but what's interesting about those two colors, the red and the green, is as you go down, they're both from atomic oxygen. Mm-hmm. So they're both pretty high up. But as you go down deeper into the atmosphere, that green color is, atomic physics tells us that it has a lifetime of 1 second. The red color has a lifetime of 126 seconds. So the deeper you go, the denser the atmosphere gets, the more the collisions happen, and that 126, that excited atom can't stay around for 126 seconds. It collides. But the green can. So what happens is you see if you look back at some of those pictures, you'll see the red above the green.
I see. Okay.
And that's because of the density of the atmosphere and the properties of atomic oxygen.
What is the relationship between the sun and auroras?
Yeah. So it all goes back to the sun, and that explains why over the last couple of years we've been seeing them more. I think at one point you were saying, someone called you and said, go out and look outside.
Yeah, exactly.
Right?
I got a text and they said, look up. Right.
Yeah, well, I think back in the mid-'70s, my mother said to me, go out and look outside for aurora. Mm-hmm. And so we went out and looked outside. It was still daylight. clearly we were missing the point. But the idea was she probably saw it on a meteorological forecast that, hey, you might see aurora this night or something like that. And why then? Well, because the sun goes through periods of activity, from high activity to low activity back to high activity in roughly an 11-year cycle. And when the activity is high, you get a lot of sunspots, you get a lot of localized magnetic field regions, you get a lot of flares, which are emit very high energy radiation that travels to Earth in about 8 minutes. And during periods of high activity, you start to get what are called coronal mass ejections. Essentially, they're explosive events in the sun's corona that then head out through space. And we observe these usually by satellites that are orbiting between the Earth and the sun and watching the sun, and they have what are called coronagraphs, so they can see these explosive events head out. Now, in certain cases, that explosive event, which is going to have a lot of density, a lot of protons and electrons, very high speed, also carries with it the sun's magnetic field out towards us. Certain cases, it'll be directed towards Earth and not, for example, to the left or the right, but coming right at us. And it can take about 2 days for it to get here. It can take a little less than a day to get here. And the first inkling that we'll have that it's near here are those satellites that are out in front. They'll detect big enhancements of particle density. They might show the flow speed enhanced. And as I said before, the Earth's magnetic field, the region that it dominates is called the magnetosphere, and it's sitting there in the solar wind. And it's very much like a rock in a stream, right? You've got on the front side, you've got bubbling up near the rock, right? And you usually see a little tail going out behind it. Same sort of thing. But now we're taking that stream and we have within it this big shock, and it's going to hit the Earth's magnetosphere, and it will create, right at the magnetopause out in front, electric currents will flow to try to shield us. And those currents will be detected on the ground. We can start to see them. And then, as if the solar wind's magnetic field is pointing southward, it is favorable for connecting to the Earth's magnetic field. And solar particles will gain entry into the Earth's magnetosphere. And actually what they do is sort of fill up the tail. And they'll, under some tension, they'll come back towards Earth. And as they approach Earth, they'll create this, positives will go one way, negatives will go the other way. They create an electric current. And that electric current is going to alter the Earth's magnetic field some. And the details of how it does that are pretty complicated, but it allows the aurora, which is happening all the time in an oval surrounding the North Pole, it allows it to expand down to lower latitudes where we might see some of it. Yeah.
Okay, so you mentioned that there is a solar cycle. Why is it about every 11 years? Is it something to do with the size of the sun or the distance from Earth? Why every 11 years?
I don't know.
Okay.
It is really, it's interesting. And this is not my area, right? I look from outside the sun coming out. But an interesting clue, let's say, is, and it has to do with the dynamics in the interior. And an interesting clue is during that 11-year cycle, the sun's magnetic field, and it has a magnetic field that gets carried out with the solar wind, it flips every 11 years. So it's very much due to the inner roilings of the sun and whatever circulation patterns are there. But what's interesting, right, is that the Earth's magnetic field also undergoes periodic flips in its magnetic field. That it's been a long time since I've looked at that literature, but I think it's roughly on the order of 100,000 years, and they've been able to do some very I think they've been doing some pretty accurate modeling on that flip, and it's due to the circulation in the molten core, I think.
What opportunities are there for research and study of auroras when they do come to lower latitudes, like in recent weeks? For scientists like yourself, why is that exciting?
So for me, this was my PhD work and my postdoc work, and I've involved some students in it, but I've been a little less involved with it the last few years, though my students will tell you that I bring in examples any way I can. What was most exciting for me? My son's at a college on the coast of Maine, and he took a beautiful picture, and he sent it back to me. And and it started a discussion.
Mm-hmm.
And so it really it's just nature's most amazing phenomena, and to know he experienced it was fantastic. On the other end, why do we start to study these things? When I was a grad student, and I haven't been a major part of the field for a long time, but when I was a grad student, the field of space weather was really starting to come of age. We were just chatting about the fact that, hey, they say, hey, aurora's coming, and we don't see it, but we're reaching a point, on the other hand, October 10th, when you were told to go out and look at the aurora, we had pretty good advance notice of it.
Right.
And it pretty much happened just the way they said it would. And so predicting the energy and momentum as it leaves the sun and then propagates through the solar system and the solar wind, and then arrives at those first satellites outside the magnetosphere, and then starts to hit the bow of the Earth's magnetosphere, and we can start to see signatures in the magnetometers in the ground. And then a little while longer, it starts to fill the tail and the ring current, and we start to see the signatures on the ground, big signatures of a magnetic storm. And then the tail is very full and very sensitive, and process happens in the tail that energizes those particles, and we get a substorm, and they go towards the polar regions of the Earth and create these dramatic displays that move to lower latitudes. And with the vibrant colors, with the electron density in the upper atmosphere, all of those things, and then you start to see the magnetometers on the ground in the polar regions react to understanding this entire process, beginning and end, tells us so much about the fundamental properties of what we call plasmas, which are ionized gases with these magnetic fields. But also, these have effects on terrestrial systems, the communications, the power companies, those electric currents on the ground. They can induce large voltages in electric power grid systems. In 1989, it actually shut down the Quebec power grid. So our ability to study that beginning to end and then learn the intricate details in between helps us manage our technological systems, but also develop new technological systems that we can use in the future.
Dr. Hugh Gallagher is an associate professor of physical science at SUNY Oneonta. You're listening to The Best of Our Knowledge. I'm Lucas Willard. The Northeast is experiencing an historic drought. Multiple states have declared burn bans amid a lack of precipitation and a record amount of wildfires. To learn more about the conditions on the ground and what has led to this atypical fall season and increased fire risk, I spoke with Samantha Borisoff, a climatologist with the National Oceanic and Atmospheric Administration's Northeast Regional Climate Center at Cornell University.
This dry pattern sort of started in earnest in September. Mid-September in particular, we started dry outs. But then October came, and October was exceptionally dry. And that's putting it mildly. So for several places, New York City, Philadelphia, Newark, it was the all-time driest month on record. And so a few of those sites, for instance, Philadelphia and Newark, it was the first month without any measurable precipitation on record. And so Philadelphia has records that stretch back to 1871. So this is the first month that Philadelphia has ever seen no measurable precipitation in a single month back to 1871. So that is impressive. The sheer lack of precipitation that large portions of the Northeast have seen, particularly in October, very impressive historical numbers.
Obviously, it's been a very dry past several weeks, but what is a more typical weather pattern for this part of the country?
Sure, yeah. So, with typical October weather, it can be pretty changeable. We're kind of transitioning from, summer, and even September, right, can kind of be a little bit more transitional, but we kind of think of September to be a little bit more toward the summer side of things more so recently. October tends to be a little bit more transitional. We can sometimes get these convective storms that we would see, let's say, in the summer, like thunderstorms, for instance, but we also are transitioning into the more wintertime, like atmospheric patterns, which tend to bring kind of more larger, wide-scale storms across the Northeast. We can sometimes even get fall nor'easters, but then also we're still in the time of year where we can get, hurricane and tropical system remnants coming up the coast as well. So typically in the autumn, it can be a drier time of month, but we do typically see the ability to kind of have multiple different types of precipitation patterns moving through. So while it tends to be a little bit more of a drier time of year, we typically do see at least some of, one of those three types of, weather patterns setting up where we get either thunderstorms or kind of just a widespread, low pressure system or the remnants of a tropical system. And we haven't seen any of that, this month. So very atypical.
Now, it's been warmer for the past several weeks, but I woke up this morning and it was pretty cold out there. Does the actual air temperature have an effect when it does get colder, have an effect in dampening any future fires? Is warmer temperature one of the magic ingredients when it comes to fire risk?
Sure. Yeah. I mean, warmer temperatures definitely do not help the situation. So you're right. We've had warmer than normal temperatures in September, in October. To kick off November, we actually had a couple of sites that had their warmest high temperatures for the month of November. So during that first week of November, temperatures have been unusually warm as well. And so what happens is a couple of things. With warmer temperatures, warmer air can contain more moisture, so that drives increased evaporation. And so when we already have a situation where conditions are already dry, there's less surface moisture already out there, right? We've been dry. Those warmer temperatures increase, the thirst of the atmosphere. And so what happens is that drives, again, more like increased evaporation. And so also what happens is because there's less water at the surface, some of that energy goes into heating the air around it. So again, it just creates sort of this feedback loop where you get these warmer temperatures that increase evaporation, but surface conditions are dry. So, evaporation is limited. So the air gets heated, it gets thirstier, and we kind of get into the cycle. And what happens is, when you're already in a drought, it can make existing conditions worse. We're also seeing, that could also drive, those warmer temperatures, water demand, the agriculture season stretching a little bit longer. Folks, might be watering lawns or using water in different ways because, right, like we're already sitting, with drier conditions. And so there's plants that are still out there growing. And so the growing season is extended slightly with these warmer conditions as well. And so the water use for, certain plants may be increased as well. And so it all kind of ties together. So the warmer temperature certainly, feeding into it as well. And it's funny that you mentioned it was cold because, temperatures are actually falling, for a very short period of time back to where they actually should be. So it's kind of that we've been warm. So as folks are kind of heading out, they're like, oh, it's cold. It's actually more normal, these temperatures that we're seeing. As far as it's not really necessarily cold. It's more that's more where we should be for this time of year. These temperatures that we've been experiencing are warmer than normal. That's not how it should be this time of year.
So when you look at the patterns that we've seen in recent years, looking ahead, are droughts going to be more common in this part of the country with climate change? Is that a distinct possibility?
Sure. So, I think a lot of folks typically think of, the Northeast as being a water-rich region, and we are, but we also can and do, as we're seeing right now, have significant droughts at times. And I think folks do need to know that we do have these extremes and that we will likely see these extremes in the future, and we need to prepare for both ends of those extremes as we head into, the coming, years, decades, century. And another, tie-in with those future conditions is the increase in temperatures. I kind of talked about that feedback loop. And so that ties right in with climate change. We've been warming. We expect that warming to continue. And so, that drives increased evaporation and kind of that whole feedback loop where it can either, it can kind of help put us into a drought or intensify existing drought conditions. So we need to be prepared for both extremes of the extreme rainfall that we talk about a lot in the Northeast, but also, the significant drought that we're experiencing now and will, possibly see in the future as well.
Now, when it comes to water supply, and I'm thinking drinking water reservoirs or wells, can we expect, because of a dry fall, future conditions maybe in the winter or spring where water shortages may be common?
That's a really good question. I mean, in terms of the recharge and of reservoirs and things like that, that's not personally something I typically keep a lot of an eye on. That falls more in the hydrology side of things. And there's a whole team of folks that kind of look after that. But what I can say is, yes, I mean, we need to be getting precipitation now to recharge, surface water levels, groundwater in particular, especially in northern areas. Once the ground freezes, it's really hard to, it's the recharge of groundwater levels is pretty limited. And so if we don't get a significant snowpack that would melt in the spring to recharge those groundwater levels, there could be some areas that are going into the spring and summer, already with lower than normal groundwater levels, surface water conditions, and things like that. So we certainly need to start to see that recharge happening now before we get into the colder months, especially if we don't get a very good snowpack. I mean, that could really set us up for a bad situation going into the spring.
So there has been an unusual amount of wildfires this fall across the Northeast, but also in recent years, we've seen very smoky summers with wildfires burning in Canada and smoke drifting across the continent into the Northeast. Is just more wildfires going to be an unfortunate reality of climate change? Is that something that we're already seeing and you expect to continue?
Yeah, that's a great question. And yes, I do see the tie-in there with, climate change. We were talking about those extremes. And so, and the warmer air temperature. So there certainly is a tie-in there with, I would say yes, with climate change, we could potentially see more wildfires. I don't want to speak to the West Coast or Canada because I'm not as familiar with, the conditions out there. But, in general, it makes sense that, if we're seeing, increased evaporative demand and, those warmer air temperatures, that as we dry out and we get drought conditions, there is the potential for increased wildfire risk along with that. So I would say that there is a tie-in, but in terms of, the specifics of kind of the Western U.S. and Canada, I don't really feel quite comfortable talking about all of that. One of the questions I'm going to ask quite a bit is kind of, when could there be relief, and if there's going to be precipitation or anything, and kind of what the outlooks look like. And so I was just going to mention that right now the weather outlooks for the next 7 days really show little, if any, rainfall. And so we do expect that conditions would, likely persist or maybe even worsen if we don't get any rainfall over the next 7 days. And then beyond that, NOAA's Climate Prediction Center puts out outlooks for shorter term, usually for a 6 to 10 and 8 to 14 day period. And so, we just say that it does show above normal temperatures are favored for the region, and then near or above normal precipitation, which might sound great, right? Near or above normal precipitation, but it's going to take multiple slow soaking rain events to really dig ourselves out of these precipitation deficits, because since the start of September, places like New York City and Philadelphia and Newark, they are lacking around 8 inches of rainfall. So from the start of September to now, they should have had around 8 inches more precipitation than they have. And so that's a really big deficit. And I know folks that, were excited the other weekend. There was a little bit of rain shower activity, but really that's just a drop or two when you look at the sheer amount of precipitation that needs to be, picked up to really dig us out of this drought significantly. It's going to take a little bit of time. And I just think that kind of ties into my other point that folks really need to be careful. Most places have burn bans in effect. It's for an important reason. It doesn't take much to start a fire right now, and they really need to be mindful of the activities that could start fires and really follow those burn bans. And also, you mentioned, with the water, conserve water the best you can. It's all interconnected. Each of us really just does need to do our part, because right now we're stuck in a pretty bad situation, and it's going to take a little bit of time to dig us out of this.
Samantha Borisoff is a climatologist with the National Oceanic and Atmospheric Administration's Northeast Regional Climate Center at Cornell University. This has been The Best of Our Knowledge, episode 1780. The Best of Our Knowledge is a national production of WAMC Northeast Public Radio. Thanks to associate producer Madeline Reynolds. The latest on all National Productions programs is available via the Airwaves newsletter and our flagship station's website, WAMC.org. Until next time, I'm Lucas Willard.